one way or another. You can either grab it from the chat or find it there. So yes, I'm Dr. Jessica Hartnett. I am about 2 hours from Canada in Erie, Pennsylvania. Land acknowledgement, this is the traditional lands of the Mississauga and the Haudenosaunee, people. I have my email address right there in case you want to reach out to me. My blog that you talked about, I've been doing that since 2013. I just checked it. I believe we are up to 450 blog posts about teaching of stats. And I'm also too active on Twitter under the username Not Awful, because my blog, I like to set a low bar for everyone's expectations, FYI. So it's not awful ideas for teaching stats. Sometimes they're hilarious and brilliant, but they're always at least not awful. And before I talk about the idea of what do psychology majors need to know about statistics, why don't we talk about what you need to know about sitting in a chair all day? I'm aware that this is the last talk, and I thank everyone for hanging in there and joining me here. Cleveland Clinic, about 2 hours west. You might join me in some yoga on the go because you've been sitting around for a while. Maybe you've taken some breaks. I'm ready to write a paper called Professional Development and Laundry Folding, a case study from this experience I've had here today. And I hope I can make this worth your while by talking a little bit about some broader issues about teaching statistics in the Psych curriculum. So I want to share some things about me, not to talk about me, but so you know where my ideas are coming from. We're not a monolith, right? Some of us are teaching 300 students at a time, and some of us are teaching 10 students at a time. How do I teach? I've been at Gannon since '09. I graduated from Northern Illinois University with a PhD in social and industrial organizational psychology. And I teach at a for reals liberal arts college. I teach a 4-4. I teach honors psychological statistics. I teach regular old psychological statistics and also online psych statistics, which is also a condensed 7-week course. In my 4-4, I usually have one elective and then 3 stats classes. Our stats class here at Gannon counts as the quantitative credit across the university. So me and 3 other professors in my department teach about 7 sections a semester, which for a university our size, about 3,500 undergraduates, that's a lot of classes. I teach anywhere from 10 to 30 students at a time. I teach with JASP. We made that decision as a department. We decided that JASP was giving us what we could get out of SPSS, but it was free, more flexible, less of a ram hog. We decided to make that move as a department a few years ago. While we did make that move as a department for just teaching the undergraduate class, all of the undergraduate psych stats instructors can make their own decisions about what exactly it is they teach, how they teach it, textbook, software. I do teach in a computer lab, although more and more often students show up with their own laptops and do everything off of their own laptops. I don't have a TA, and I do work at a place that walks the walk when it comes to undergraduate teaching. Truly, I feel rewarded for being a good undergraduate teacher. It's written into our rank and tenure language. And again, I mention all of this because some of the things I'm going to talk about and some of the suggestions I might make may not fit at the scale you're working at. And I respect that. And I hope that maybe we can talk about rescaling things or mixing things up so some of my ideas might work at a wider variety of universities. So what do I want us to chew on today and think about? I want us to think about what a psychologist is versus what a psychology major is. And I do believe there's differences. I want us to think about what we want our students to leave the university with in terms of statistical knowledge and know-how when they're trying to negotiate their whole entire life after they leave with their bachelor's degree. I'm going to walk the walk. I'm not just going to give you some highfalutin opinions. I'm going to give you some readily applied activities and ideas that you can use in your own classes. And then I'm going to go a little broader and talk about maybe how we can use our bachelor's degree programs to best serve the statistical needs of a lot of different psych majors. So why do I think this is time for this talk? I think we're all doing our jobs within a lot of constraints, right? We have accrediting bodies and we have departmental politics and we have good departmental rules for how we teach and dumb departmental rules. Some of us are co-teaching or teaching as part of a sequence. So I understand that not all of my ideas will apply to your situation, but I would like you to sit and think for a little bit this afternoon as you're kind of winding down and think about what a psychology major is and what statistics they're going to need in order to succeed in life. And maybe we can think a little bit more about the curriculum. So to start, who are we teaching, psychologists or psychology majors? So who is a psychologist and what are our majors? Who are psychologists? By and far, when we think psychologist, I think that what comes to mind in the general population are clinical and counseling types, right? But I think amongst professors who are teaching statistics, when we think about psychologists, we think about ourselves, right? We think about those of us who are professors, who create and scrape up and analyze data. We produce it, we consume it. And that's one aspect of who a psychologist can be, but it's also a pretty privileged perspective when you think about it. I have a link here, and again, you'll be able to access all of this since I'm sharing this PowerPoint with you. But I think it's really interesting. They did a study from the New York Times with the jobs you're most likely to inherit from your mother and father. And you can scroll down and enter in a job. You can also look, they have lots of data here for you to look at and make your way through. But for professors and lecturers who have parents who are professors and lecturers at a rate 5 times the rest of the population, and this is higher than most of the jobs on the list that they had. So again, who's making it into the academy? A lot of people that maybe have some inside tips and knowledge about doing so. And also, if you're able to make your way into the academy, you're probably a PhD who had the support to be poor for 6 or 7 years, right? And work on that PhD. And I think to be a psychologist in this aspect is like an endpoint for some people, but not everyone. I contrast this with who are the psychology majors. And of our majors, there's very few future academics that we're teaching. I know, like, it's kind of dear when we have a mini-me, right? Like when we have a student that does go into graduate school, and it's super awesome when we can like co-author with them later, right? And then they turn into a colleague, they're not a student. That's wonderful, but there's really not that many of them. And I have some data to back that up. Many of our students aren't going to identify as psychologists professionally. Psychology majors are going to confront data. The world is data, the world is statistics anymore in a lot of ways. And they're going to confront data and have to work with that data, but it's not necessarily psychological research data, right? Spreadsheets. They're going to be citizens in a world where they need to understand science and statistics and research methodology in order to make sense of people trying to persuade them and people trying to get them to think one way or another. And our psychology majors are still figuring out who they are. So to back up some of my bold claims, one of my claims was that very few are future academics. And where does this data come from? This is another friend website. So again, I'm American, so I'm going to talk about APA. But I think that these findings probably generalize to some extent. And APA organizes the workforce data. So this is the Center for Workforce Studies data, and amongst all of them, if you're a data type, and I assume if you're here, you're a data type, this is a lovely rabbit hole to go down someday. But they talk about, this graphic shows the degree pathways for 3.7 million individuals who held a bachelor's degree in psychology in 2019. All right, so where did they go? 57% of them didn't go any further than the bachelor's degree. So that's the majority of the students and who we're dealing with. And I know that this probably varies somewhat from organization to organization, university to university, but overall, these are the findings. 29% obtained higher degrees in other fields, and only 14 obtained higher degrees in psychology itself, with 4% getting a doctorate or professional degree in psychology, which is where I quoted that in the abstract. All right, so here's our psych majors. Here's some ideas about where our psych majors end up. And again, your university may have different data on where your students land, but this is a broad piece of information. One number, I think it's all fascinating, but I think this 29% number is interesting. For where are these master's degree students who aren't getting psych degrees? And I pulled that data out. It's over here. 17% are going into social work, MSWs, which is a pathway to seeing clients and serving as a mental health provider, right? Special education also pretty much makes sense, right? If you are interested in clinical populations, if you're interested in working with kids, special ed's a good home for you. A lot of elementary teacher education going into that, and also counselor's ed, which my reading of that is like K-CREP counseling organizations that don't identify as psychology organizations, they're counseling organizations, right? And that's what a lot of our students, where they're ending up when they don't pursue psychology graduate degrees, but they are pursuing a variety of different master's degrees. So that's one segment of the population. What about the bachelor degree students? All right, fair warning, I'm going to show you a word cloud. I know some people aren't crazy about the word clouds, right? Here it is. So this is also from the APA website, and this is from in 2019. And an estimated 1.5 million individuals in the workforce had a bachelor's degree in psych. And this is what they did. I'm being quiet because it's a lot to take in. So lots of others, lots of not otherwise specifieds, right? You still have social worker over here, right? And you have statistician, itty bitty statistician right there. And counselor is there. Again, this is American data. I know that depending on the state that you live in, what you can kill all yourself and what you can be qualified to do with a bachelor's degree differs wildly, right? So there are some of those categories recognized amongst the bachelor degree holders. And this is a lot. So if you're really thinking about who are psych majors and where they're going and what are we preparing them for, this is a lot, right? So what statistics do psychology majors need for life? So who are we teaching? A lot of people who are interested in human behavior, a lot of people that require training to understand psychology, and that certainly involves statistics and research methodology, but they're probably not going to get a quanti master's degree, quanti PhD, if a PhD at all, right? So maybe we need to reflect on what's carryaway messages do they need to know? What do they need to know 5 years post-bachelor's, 10 years post-bachelor's? And I want them to know a broad set of skills that's going to help them in whatever profession they decide they're going into. College is way too expensive for that to not be something that we take into consideration. Again, American perspective, I guess, on super expensive college, but you get what I'm saying. I want to teach them things that they're actually going to remember. How many of us have ever had that point where like you're teaching like one of your senior students that you've had in classes before and they like still don't know what a DV is and what an IV is? Bless them. But again, they don't always remember it all. I need them to understand that statistics isn't a psych-specific tool, that it is an amazing tool that will get them jobs that they're going to see again in their lives. Call me selfish. I want to live amongst informed people that understand stats and research methods and how to seek out answers to questions and how to recognize a good scientific explanation versus not. And I also think, and this is an equity issue, I think that they may need free software. And I think that we should start looking at free software packages as an equity issue. And there's plenty of good ones out there. Excel, Google Sheets, R, Jamovi, JASP. Again, we went away from SPSS for a lot of reasons, but the cost was one of them, and having to access it from off campus was another one. And like I said, a lot of my students like bring their laptops to class and do the examples in class, and those are a bunch of freely accessible computer programs for them. All right, now I'm going to get a little controversial for a moment. Admittedly, your mileage may vary. What very useful, even sometimes very profitable knowledge may they not use again after they leave their bachelor's degree? Coding at the intro level. You don't need to agree with everything I say. That's okay. I did a little survey with Janet Peters at Washington State University Tri-Cities. We presented it at the National Institute for the Teaching of Psychology, NITOP, in 2020, and then COVID happened, so it's still just a poster presentation. That poster is shared via that link I gave you. It's in that Google folder. And according to the 98 psych stats professors we surveyed, 10.4 of them were using R to teach intro level psych. And I think some people do that really well. I think it's a really good skill to learn. I think that a student with a bachelor's degree and a robust knowledge of R is going to out-earn me. And I think I'd high five them and ask them to talk to like our advancement office, right? Good for them. But I just wonder if teaching them to code sometimes is going to get in the way of getting them to think about statistics as deeply as they could. And again, I say this from an aspect that think about your face time with your students, think about your contact time, think about the time when you actually have their attention, where they're not at one of their other 4 classes, where they're not thinking about dinner or their fight with their roommates, when we actually have them and they're concentrating on the class. I think there's something to be said for using the graphic user interface instead of code. That said, I think coding is a really good skill to have. What else do I think our students won't ever see again after their bachelor's degree? SPSS. I think it's going away. I think it's still very popular. About 60% of the 98 psych stats instructors we surveyed in Hartnett and Peters 2020 are still using SPSS. And I think if you operate in certain circles, especially in the Twitterverse, you just think everyone uses R. That isn't the case. And again, I think that that decision to use SPSS may be out of your hands as an instructor. I don't think SPSS is inherently bad or evil. If that's what you learned and if that's what gets you published and has gotten you tenure, you do you, right? But I do think that it's subjectively expensive. And something else I think is we need to stop doing test statistics by hand. I think there is knowledge to be gained by solving a linear regression line and standard error and figuring out standard deviation. I think there's something to be gained with that. With our limited class time again, are you going to concentrate a whole lot of time on your students adding and subtracting and squaring and square rooting? Or do you want to teach them more big picture stats issues? And with that comment, I know that that could also be interpreted as snobby because there could be an equity issue where if you and your students don't have computers, you don't have computers, right? And that's how you're going to calculate your test statistic. You're not going to let a computer spit it out at you. What else do our students need to know stats wise? I think some of our students are going to need stats for accrediting bodies and continuing education units. This top slide I have are the 8 K-CREP domains on which the examination questions are based. So K-CREP certification, which goes back to that category of students who get master's degrees that are not psychology and are looking at counselor's education. That's what they're looking at. And there's certainly research and statistics on their accrediting exams, which reflects on the fact that they need to keep up with their research in order to be good counselors, right? And the social work accreditation is similar. If you look over the accreditation standards to become a licensed social worker, you need to understand some stats and research methods as well. Regardless of the job they're going to have, they're going to spreadsheet again in their lives. So let me start over here. Oop. Freakonomics Radio and this link down at the very bottom. I'm sorry, it's not a clickable link. I forgot to do that. So you remember the Freakonomics book because it is stats heavy, right? And it has to do with a lot of applied economics. It's written by two Stephen Levitt and Stephen Dubner. And they've written sequels and now they have a podcast. And they did one podcast that was dedicated to America's math curriculum. And if you're a stats nerd, and if you're here, you're probably a stats nerd, go listen to this episode because it's fascinating because they talk about the fact the American math curriculum was initially basically based on the space race with Russia and making everyone an engineer. And now the math curriculum, the K-12 curriculum is really based on prepping students for the SATs and ACTs. right? But it's not prepping students to be grown-ups and adults. So Stephen Levitt worked with a think tank at UChicago, and they asked people questions about what stats are they using now in their day-to-day life and what math are they using. And their big takeaway from this whole talk is that stats education needs to be more integrated in K-12 education. So he's working with Dr. Marchniko, sorry. And they're asking about, like, what do people use mathematically at work? And what was the answer? Yeah, close to 70% of the people said that they use Excel or Google spreadsheets on a daily basis. We asked people how often they visualize and present data to make an argument. So if you include those who say they visualize data daily, weekly, and monthly, you're going to get over 70%, up to 75% of people, which is a lot. Right? So we might be teaching fancy stats, and we have to teach the fancy stats and the inferential testing, but students also need to know how to work spreadsheets. What else do they need to know? So they went through, and the students aren't using a whole lot of information that they used in traditional math topics. These adults aren't saying that they wish they had learned more of the traditional math. But to go back to data skills, what does the data say? Yes, on every single one of the data related questions we asked, over 40% of the people said they wish they had learned more. But the one that really stood out was how to analyze and interpret data to discover hidden insights. We had close to 65% of people say they wish they'd learned more about that. So we're doing good, guys. We are giving skills and knowledge that people are going to use. But I would like to return to a second about the question of managing spreadsheets. I don't teach in Excel, but when I read this and I'm reminded of this, I wonder if I should. If you don't teach Excel, I would teach free. And if you do want more information on teaching a whole intro stats class using Excel, Google Sheets, or Apple Numbers, may I direct you to Dr. Morton Ann Gernsberger's online free class. She is at University of Wisconsin at Madison. And she has made her entire intro class freely available. No login, no nothing. And one thing I think is really noteworthy about the way she teaches is that she lets her students, and she leads her students to take the class using Microsoft Excel, Google Sheets, or Apple Numbers, which I think is very bold and wonderful and inclusive, right? So to appreciate why you're going to learn about a database management system such as Excel rather than learn a statistical program such as SPSS, look at this tweet. I also like, it speaks to me when people just like cite tweets for science. And this is the tweet in question, looking at how we teach our students who are going to the data jobs. And what do they need to know? SPSS is way down there. But Excel is commonly used even in data science jobs and data science job ads and data analyst ads. Yay, R's there. I see SAS there as well. Good old math labs hanging in, right? And of course, you know, SQL and Python are like power users as well. But again, if you want more information on that, I would just go and look through her whole class. It has a lot of insights. It has lots of ideas for how you could teach statistics. And I also think we need more stats and research methods thinking for everyone. I think, for instance, we need it to beat COVID and a lot of other issues, right? Like the Johnson & Johnson pause on that vaccination, right? People, rightfully so, were investigating rare but severe blood clots in otherwise healthy women, right? But you need to be able to think about base rates, right? 7 million people got their J&J and 6 confirmed cases of blood clots occurred, right? So this is about seeking out science, seeking out data, and understanding how to reason with that. I have another example from the FDA, and this is about reporting of negative side effects after taking the COVID vaccination, right? And this is about correlation doesn't equal causation. So let me take you through it. As of December 6, 2020, there were 3 SAEs, so these bad reactions, reported in the vaccine group. A 65-year-old participant with community-acquired pneumonia 25 days after vaccination, and here's the one that I think is noteworthy, a 72-year-old patient with arrhythmia after being struck by lightning 28 days after the vaccination, right? It's not funny. It really isn't funny. I hope she's well. But it just goes to show you that you need to dig into the data and understand that with these adverse reactions that are being reported, correlation doesn't equal causation. Just because something happened after you got a vaccine doesn't mean that the vaccine caused it. Unless Thor hates the vaccine, I don't know. Your students can research that if they want. And I think we just need better stats knowledge, full stop, right? This is horrible. So I love Pew Research Center. I think they're a good source of data, and they freely share a lot of their data. If I wasn't a professor, I'd want to work for Pew Research. And as part of a larger effort to kind of take the pulse of science literacy in America, they put together this big survey. And part of science literacy, as defined by Pew Research, is your ability to interpret graphs and charts. So what do we got here? We found out that 63% of American adults can correctly read this chart, which is appalling, I think. So what is this? It's a scatter plot. X and Y axis have been labeled. And even worse is that like people had 4 options, right, for selecting what this chart means. And what did we get? 63% of American adults were able to read that correctly. So this is another reason why we need stats, and we need stats education. We need stats for making difficult health choices. This is from England. And I did a blog post about this, but also about the basic website itself, which is from the NHS. And what were they looking at? They were trying to share information for parents that were going through a terrible situation. They had to pick out a hospital where their child would receive heart surgery, right? Data helps you make this decision, but how do you use data when you're terrified, right? And if you likely never taken a stats class. So what did they try to do here? They have this idea of survival with predicted range, but that could be interpreted as a confidence interval. They have all of this information for trying to make this really difficult decision. And they also actually have an amazing video here that describes confidence intervals without ever saying confidence intervals. They also describe the distribution of the sample mean without saying the distribution of the sample mean. I use this when I teach confidence intervals. How else might we use confidence interval? Just understanding weather forecasts and getting yourself out of the way of severe weather, which makes me think of that COVID example. But what's another example? You've probably seen maps like this, right? And what is this map? It is showing you weather forecasts for where a hurricane's going to hit coming out of the Gulf of Mexico. Did you know that's a confidence interval? What's the cloudy area in this map? The cloudy area in this map is where they think the hurricane's going to end up 60 to 70% of the time. And again, if you look this up on the link that I shared the original website, which was from the New York Times, that created a really cool visualization that takes you through the steps of how this is a confidence interval, but I also wrote a blog post about that. And we also need citizens who just value data and value good data and are going to get mad when data is hidden from them, as has happened a lot over the course of the COVID crisis. Like just north of me in New York State, nursing home data was hidden, and the death toll from nursing home related deaths is probably much higher than we think it is. And this is another way I've heard other speakers kind of echo this of how can we emphasize to our students that data is important and statistics are important? Well, if there's a long storied history of big organizations hiding data, manipulating data, paying public relation firms a lot of money to get people to doubt data, it must be important. And that could actually be a fun discussion day in your stats classes. And not surprisingly, I have a spreadsheet about that. So here's the spreadsheet that, again, you have access to now. And this is another way you can kind of reach out to students and try to convince them that stats are really important, I think, by showing all of these different examples. And these are just primary, like they don't get into the topic in great depth. But there are a lot of instances when big organizations lied about a thing and the industry that's related to, because maybe that would help you pick out which one you'd want to use in your class, depending on your own interests and things like that. And then a few websites about that. If you want to use something like that in class or something for a discussion topic, again, in order to engage your students and convince them that what you're teaching them is going to help them be a good citizen. So what do want my psychology majors to know? All right, I made up this metaphor. It's only 2 days old. I hope it's a good metaphor. So I want them to know that statistics aren't a strawberry stem remover, that they're a Swiss Army knife. So stick with me. So what do I mean by that? I think that sometimes when you take psych stats, and all of the examples are psych related, and you're thinking really hard about how this all applies to psych research, and you get really caught up in that, you see statistics as the strawberry pitter, right? So you think that stats just do this one thing, and that stats are used just by your professors, and just psych professors use the stats to do the things, right? But instead, I want them to realize that statistics are like a Swiss Army knife. I want them to know that they're this flexible, amazing storied tool that can be used in so many different situations by so many people. I also think that our psych majors are novices, as discussed by other speakers. They're anxious about statistics, right? And they're also busy college students. We're one of their 5 professor bosses making demands of them, right? So I don't think that they can get to that point on their own. And I also think that maybe there's also a bias amongst stats professors, because we just love stats so much that we assume everyone does and everyone can see its applicability. So I think that we need to work to make our material applicable and memorable, and they can see where it can be used in different domains. So of course, this is still a psychology major, and you still need to be thinking about what psychologists need to do and what we need to teach them about research methodology, right? And also I realize that per the word cloud, there's all of these different jobs, and we can't possibly teach all of those jobs, right? But we do need them to not just be psychologically literate, but statistically literate as well. So I would suggest that you keep your core content, because they're still psych majors and they're learning a tool broadly used in psychology. And I think you should still continue teaching that standard content. And again, from Hartnett and Peters 2020, this is some of the stuff that's taught broadly, but not everyone teaches all of this stuff. Again, you can look at that poster yourself to see what the most commonly taught topics are. But I think that maybe we need to think about how we couch what we're teaching, and maybe focus on some psychology, but less on psychology, and give some other alternate examples and work our students can do that aren't necessarily based in research. And also stop doing test statistics by hand. So with my Swiss Army knife approach, I think you need to engage your students in discussions. And again, I use discussions in my tiny little honors class. I know you might teach an enormous class, so maybe this would work better as a reflection piece or an electronic discussion board or a writing assignment. But I think that you need to show your students that statistics have a lot of ethical issues tied to them. So I'm going to double dip and share a talk I gave in February at the STP, the Society for the Teaching of Psychology pre-conference, at the Society for Personality and Social Psychology conference this year. And this one's available to you too in that Google folder. Beep, boop. And I'm gonna fly, so that was more about stats literacy, similar topic. Stick with me, don't get motion sick. So what do I think that we should do in our stats classes when we can? I think we need to talk about the bigger ethical issues and make them very compelling. So again, you have access to this. I have all of my information in a spreadsheet because my brain thinks in spreadsheets. But what are some discussion topics that you can use when you're teaching? You can talk about, because I think there's a lot of overlap between research methods and stats. You can talk about informed consent versus terms of service in this modern world that we live in, and all of the information and data that is being gathered about all of us all of the time. And here I talk about how it's a stats topic, but it's also an in real life topic, and I give some information and some links. Again, I talk about, do you guys remember the Choose Your Own Adventure books? I'm 42. So these were books where you could like flip around in the book and make your characters do different things and choose your own adventure. And you can also choose your own adventure because there's so many examples of large organizations hiding their data. And I talk about that a little bit. And of course I have that spreadsheet you already saw. I also think that it's good to talk about bad science reporting. I'm really proud of that screen grab. What is the screen grab from? You might have seen this a few years ago when John Oliver did a great big episode dedicated to p-hacking, actually. And it's a good episode. Some of the language is a little cheeky, right, for maybe AP stats in high school, but beyond that, I think you're okay. But I think that the stats topic is that they need to learn to report data clearly and truthfully. And I teach my students many APA reports. And they need to understand why clear, concise writing is important. So I don't think it comes into the stats class. It's not just a research methods topic. And it's also an in real life topic because, again, I don't want my students to be hoodwinked at every time someone tries to pass bad data off on them. And there's some other reading for you. Another discussion topic can be AI and big decisions. And again, I mean, AI, machine learning, all of this fanciness comes back down to statistics. Like at its heart of its heart, like it's super duper fancy regression in some ways, depending on the method that's being used, right? And I think that your students have to talk about that. I call it fancy regression. And I think it's a good topic because, again, it's an equity issue, right? Because time and time again, we're seeing bias and racism and prejudice being cooked into the code that's being used. And a good example of that is this AI in medicine from Forbes that I share. There's some better examples of things when it goes well and a primer for you as well. And finally, I also have beloved ideas that are not supported by data. And this is another reason why students need statistics. And I use this when I'm teaching about null hypothesis, statistical testing, and effect sizes. Data collection and analysis are necessary to verify ideas, or let's not say verify, like provide support. Intuition and anecdote may inspire research, but they don't prove anything. And I talk about learning styles. I talk about vitamins and snake oil supplements and how we can't find that they're helping us out a whole lot. And also this is one that it doesn't lead to angry discussion, but it can lead to emotional discussion. There's a lot of people questioning whether regular breast cancer and other cancer screening actually reduces cancer death rate and whether or not it's appropriate broadly and in all populations. So again, I'm just warning you, if you do use that one, it can be a sensitive topic for students. Okay, so Swiss Army knife. Those are some discussion ideas, and I know I kind of flew through them, but you can peruse them in your own time if you want to use those later on to teach. Also, what other suggestions do I do over the Swiss Army knife? I think you need to couch your examples in the everyday and not just psych theory. So if you've taken a psychometrics class, you've talked about double-barreled questions, right? And these are questions that are secretly asking you two things, but they're worded as to be one thing. So like you could look at like, was your check-in at the hotel like fast and friendly? Like you could have like a really friendly hotel attendant who's so slow because they're talking to you, right? That's a double-barreled question. You can't just have one question to answer that. So I also wonder, okay, so we're all familiar with our psych theories, and the theories that we think might be really easy to understand aren't necessarily really easy to understand to that 19-year-old you're teaching, right? So I question, if you're introducing a student to t-test or ANOVA for the first time, and you're couching your great big teaching example in psych theory, then they secretly need to understand two things, right? They need to understand complicated psych theory and the stats. I'm not saying to get rid of all of the psychology in your psych stats class. That would be absurd. But I'm just saying that you need to be cautious about these examples where, like, as the enthusiastic psychological statistician, you're thinking, oh, I'm double dipping. I'm getting like 2 lessons in one. But you also have to think about your stressed out student who may be anxious and you're one of their 5 professor bosses, right? So I think sometimes the better thing to do is, in addition to the real psyche examples, is have some memorable examples and some silly examples even. I'm going to share some of those. And this is anecdotal, but does anyone else have like the exam margin phenomena when you see that your students are like quoting you directly or quoting your stupid mnemonic device or a stupid meme that you shared, like in the margins of your exam because they're using that to guide their thought process? I just re-recorded all of my notes from my online stats class. Someone else was talking about how valuable it is to have like online lectures, recorded lectures that your students can access at any time. And I agree with that strongly. And I was talking about standard error. And whenever I teach standard error, I try to kind of go off of standard deviation and talk about standard error as a specific kind of standard deviation. And I don't know why, but I just was talking about standard error as fancy standard deviation. And I kept on saying, you know, it's just standard deviation, which you understand, but it's like fancy. And I explain how it's not just looking for the variability that exists in one variable, you're looking at the sampling distribution, right? And then when I got the students' exams for the essay question about tell me the difference between standard error and standard deviation, a bunch of them were using the word fancy, but they were also giving correct answers. And they weren't just mimicking me or parroting me back. They were answering in such a way, and the question was written in such a way that they were demonstrating a deeper knowledge, all because of fancy. And I think fancy helped. Another example I have where this comes up, which is a silly example, is my Taco Bell sauce example for Chisquare. And this came from Sean J. Taylor, who's on the Twitter. And he posted this. So we failed to reject the null hypothesis that Taco Bell distributes sauce packets with equal probability. And he even listed, he did the analysis, right? And I use this in my Chi-Square classes because it's not psychology, but it's straightforward. And it's kind of funny, right? Because who amongst us hasn't been through Taco Bell, you know, maybe after a night at the bars, and like, do you want sauce? And you say yes, and you get like a million sauce packets, right? And because I tend to take jokes too far, if you do go to this blog post, I entered the data into a CSV file for you if you want to use it, and also a JAS version because I teach in JAS. And there's the data if you want to copy and paste it, because I do take jokes too far. But again, students talk about that on the exam when they're trying to talk about the Chi-Square goodness of fit, because it's a silly, stupid example, but it sticks out. So don't let it be said that I'm all talk. And in the words of Lizzo, if I'm shining, everybody gonna shine. So if I've got some good examples, I want you guys to have some good examples. And again, the whole point of this talk isn't to ask you to change everything, but maybe ask you to change a few things, right? And I do this in the spirit, again, of NITOP, the National Institute for the Teaching of Psychology, which really concentrates on giving psychology instructors action items that they can actually follow through with and integrate into their classes. So I'm going to give you 3 examples of silly examples I use in my classes in order to teach topics, and some of them aren't even silly. I use them as extra credit assignments in my online class. Because the extra credit, there's substantial extra credits, and I feel like the online students need that extra oomph and they need the extra chance to practice their skills. Again, as other people are talking, I mean, I don't get that FaceTime with them. It's a totally asynchronous class, so I want them to have more examples than possibly necessary, but also if they don't do the example, it's extra credit, so they aren't hurt by that. I know not all of you teach stats the way I do. So these examples could be homework assignments. They could be lab assignments. They could be in-class activities that you do with your students right during class time. You could divide your students up into small groups and do these activities, right? So again, I'm giving you this general idea, including data when appropriate, and I'm also going to share slides with you. So again, I really want this to be easy for you to integrate, but you could do it in a couple of different ways. And again, what's the goal? I really want my students to have the silly, memorable example, but also be forced to generate their own data set, enter it into Excel, practice that skill, and then practice data analysis via JAS, because I use JAS. So what's my first example? Confidence intervals. And what example am I using for confidence intervals? Why, of course, Nathan's hot dog eating contest data. What else would I use? So let me open up this PowerPoint within a PowerPoint within a PowerPoint. It's like stacking dolls. So what do I do for extra credit in the confidence interval week? I get them to take a random sample of data from a data set I provide them with and do a confidence interval and then report back on whether or not the true mu was actually in their confidence interval. And what data do I use? Again, Nathan hot dog eating contest data. So to the non-Americans, I apologize. What's a thing that we do in America? We have eating contests to see who can eat the most food in a shorter period of time. Terrible for the environment, terrible for a human's body, but here we are. And a physiologist actually did research on the Nathan's hot dog contest, and this is really gross. Just preparing you. So he actually did research looking at the human stomach and how many hot dogs professional hot dog eaters can eat, and try to model like the maximum number of hot dogs that a person could potentially eat. And this was indeed published in an actual research journal by James Smoglia, who also shared his data with me, which I share with you. It's in that all of these folders that you can access. So what do I ask my students to do? There's a great amount of variability within the number of hot dogs that people eat at the Nathan's hot dog eating contest historically. And the data goes back like to the 1980s. It's like way older than your students. So I asked the students to randomly select 20 hot dogs, 20 number of hot dogs that people in the contest ate, and create their own Excel spreadsheet for the data. If you want to, and also maybe this is part of your curriculum, you can introduce them to like a random number generator, right? And they have to use that number, that has to generate 20 numbers between like 1 and 200 or however many data points there are, right? So you could integrate that if you wanted. And then what do they have to do? They need to use JAST to get the mean and standard deviation for their own hot dog sample. Then by hand, again, there is some good by hand work to be had. They have to do a 90% confidence interval. And then they need to report back on whether or not it contained true mu. And I give pretty explicit instructions about what I want from them. I have another t-test. So there's some sports data shared before, and this is another sports data example, but it's very customizable based on student interest. And this is how I have them review t-tests. And I don't have any data to share because everyone will generate and find their own data online, which is another perk of this example because it forces students to look around for data online and start to realize how readily accessible it is. The reason I use a sports example is because sports is data, right? There's just a tremendous amount of data collected about athletes and collected about sports. And because it's about sports, students can opt into a team or a high school or a particular sport that is of interest to them. This example is best used after they get into T because they need to figure out at least one T-test design question that could be answered with data they can find online that's sports related. So for one sample, is the average woman's height in inches different from the height of the 2016 women's gymnastics team? For paired, by position, is there a difference between total yards run for Steelers between 2009 and 2010 match on the position? Independent t-test, heights of women on the 2000 Irish Olympic volleyball team versus the 2000 Canadian Olympic team. I also like this example because you don't need to be very sports literate in order to find some data, right, and try to compare the data. And I also have some chi-square example. This chi-square example could also be used for a NOVA or t-test. And telling my students it's the one day that I'm going to encourage them to use social media in my class. And basically, what are they going to do? They're going to gather, for the chi-square example, a bunch of nominal data from nominal categories of data that are available via social media websites. And they're going to run a chi-square test of independence. So again, I always give them the purpose of the extra credit. And I tell them that they need to find some nominal data and maybe come up with their own nominal categories. So is your friend's profile picture a selfie or not? Has your friend posted at least once in the last week or not? Do you know this friend because they're a family member, a friend from high school or other? The list goes on. And this also knocks over their head, I think, with chi-square because it's a non-parametric test. Like the way we're counting things is a little bit different than if we're using like ratio data. And then I have them come up with their own data sets. So I gave this example here. It's my data. I gathered it by going to my Facebook friends profiles and recording their number of Facebook friends. And that's the FBFR. And I had a category of 1 for 0 to 249, 2 for 250 to 499, et cetera. And who is in their profile, 0 for no people, 1 for one person, 2 for more than 2 people. And this is my cousin. Her photo is her in like an elevator with a mirror on the ceiling. So it's her and her 3 daughters, and she has over 500 friends. So I coded her thusly. And then again, instructions for what my students are supposed to do with that data. This is also a nice example to use in class because you can use this for, you can like see how you could do t-test or ANOVA, right? You just have to collect the right kind of data. It's also nice if you want to get into a broader discussion of all the flipping data that's being collected from us by these social media websites. And you can even go into like Facebook and like look up Facebook engineers and the data that they're publishing. Not with any sort of experimental manipulation. It's just they're recording every click and they're gathering data from us that way. So what are some other opportunities and barriers when we're talking about the Psych Stats curriculum, just to touch on? But Jess, what about my university mandated course outcomes? Yep, I've got them too. I think Andy Field said it this morning, but realize that you don't need to teach stats the way you were taught stats. Don't do it. Like, I get why, like maybe you love your like undergraduate like stats professor and you learned a lot, but think about how you can teach, decide what you have power over as an instructor, and be careful about that. Like make sure that, I don't know, people might disagree with the way that you're teaching stats or want you to teach in a more traditional way or feel intimidated because you're awesome and they're not awesome. It's happened to me. But you need to kind of figure out what do you actually need to bring to the group for answers for how you're teaching stats based on your curriculum and where you can kind of strike out on your own. Yes, it's often a prereq for our research methods classes, so that needs to be taken into consideration. Again, if you taught with the test statistics by hand, you're going to have more time in class for discussions and for more colorful, memorable examples. And again, I'm not asking you to completely upend your class, but maybe think about a few little tweaks you can do. Maybe you can find an older example that's dated now, or an example that someone was talking about, like read the room, and if no one's laughing at your example that you think is hilarious, maybe it's time to get rid of that one, right? But Jess, what about my PhD Quanti master's degree bound students? Jamovi and Jasp lend themselves to learning R. I think graphic user interfaces still are better for everyone learning it at the intro level, but you can segue from that to R rather easily. And again, I think R is a great skill to have. This is a curriculum issue, not a single class issue. So I have a lot right there. So as mentioned in my introduction, I'm the chair of the STP Task Force on Statistical Literacy, Reasoning and Thinking Guidelines 2.0. And we are going to present at APA 2021. That's virtual. ACT, which is the Society for Teaching of Psych annual fall conference. We've submitted to that, but we haven't heard back about that. We're going to publish our findings via probably the STP website towards the end of 2021. And I'm going to talk at NITOP at 2022 about this. So what are we going to share? In your emails, in social media, over the next maybe a month or two, you might get a survey from us because we want to know more about how stats teachers are teaching intro psych. And we want an up-to-date survey on how we're doing, what's working well, and recommendations we can make. So that's half the task force. And the other half of the task force is actually, we're creating materials so that intro to psych instructors can teach more stats in their classes, but teach it at a level that's appropriate for an intro psych class, which is already a really full class, right? So that's coming your way at the end of the year, and we'll be giving some little sneak peeks at a few conferences coming up. Outside of your department, encourage appropriate minors for your students. If you have a shining star who's going to out-earn you, good for them with their Python knowledge, right? Maybe you need to tell them to get their minor in stats. Maybe you need to tell them to get over to the computer science department, get your minor over there, right? Or mathematics. So maybe you can look at issues of minors. And I think that also helps our non-quanti students. As I showed you on that survey, maybe you need to recommend the social work minor at your university to more of your students. I also have special education. I have that italicized because at my university, we don't have any school psychologists in our department. And we have a lot of students that want to be school psychologists, school counselors, or clinical counseling types that help families and children. So I moseyed on down to our College of Ed or School of Education And I asked them, look, can we put together a minor that doesn't need any new classes, but gives our students a really thorough understanding of, for us, the laws and the rules in America about how special education needs are met and how that population is served in our schools. And they created it, and our students take that minor and then they go and do amazing things, right? Criminal justice is another popular minor, helping professions, maybe even business. And I say mention these in class because universities vary widely in how we advise our psychology majors, and maybe you're going to have a student in class who trusts you and listens to you, and maybe they need to hear that message from you. Inside of your department, you can also think about upper level electives for your Quanti PhD bound students. At my school, we have advanced research methods. We have a multivariate stats class, which is like the advanced stats class that's required for our bachelor's of science. And we also teach psychometrics. And at my university, we teach a bunch of those classes in R. So we do have R. Again, I have hesitations about teaching it in intro, but that's just me. What else could you think of? Maybe you need BS and BA options, and those BS options need to be the mathy, statsy, computer sciencey option for your students. And different universities have different focuses. I got my bachelor's degree at Penn State, and I was in like the evolution biological science, like focus track there. Maybe you need to have a track that's better for your Quanti students. So what's my conclusion here? I think we're all trying so hard. And I think the fact that you're coming here during a really trying semester, the pandemic is still here, y'all. You're making time for this conference, you're trying your best and you're interested in being good at this, right? And I think we all care about our students and we care about our teaching. And I think that each and every one of us has different barriers and different jobs, right? But my suggestion leaving this is, what's one tiny thing you can do to help grow that Swiss Army knife mindset? What could you do with your students? What's a little tiny easy thing that you could change, you could switch out, that you could replace in order to better serve your students and make sure that psychology majors, not just future PhDs in psychology, are going to go forth into the world thinking like a statistician? And that is what I have. Thank you for your attention here late on the day.